Hey guys, it's Miss Famer, and here's the Unit 5 video on functions. So back when we talked about functions, we had to know the difference between a relation and a function. So here's the definition of relation. It's a set of ordered pairs. Here's an example that's a list. The points 1, 2, -3, 7, 1, 12. It can be any set of ordered pairs, any numbers at all. Here's an example on a graph. That's just an example of random points. A relation is really just any set of ordered pairs, whether it be a list or whether it be on a graph. A function, however, is something more specific. It is a relation, but it needs to follow certain rules. A function must have every x element with only one y element. If you look at our list here, if the x's are the same, all the same, we say that it is not a function. It's not a function. If we changed it so that we had y's repeating, that's okay. The problem is when the x's repeat, it cannot be a function. And there it is. To be a function, the x's cannot repeat. So here's an example that is a function. If you look at the x's, they are all different values. That's what we're looking for to determine if something is a function. So here's a couple practice questions. It says, which of the relations below is a function? Remember, to be a function, the x's cannot repeat. So I'm going to check my x's. 2, 3, 5, 6, 2. Oops, there's a repeat there. That's not a function. 2, 3, 5, 6, 7. That must be our answer because our x's do not repeat. Now, if you look at a graph for a function, it's a little bit different because we can't always easily tell whether or not it's a function just by looking at the graph. It's hard to tell if the x's repeat or not. So there's a shortcut for this. It's called the vertical line test. The vertical line test is used to check to see if we have a function. And next to that little star there, it says if a vertical line intersects twice, then it is not a function. So I'm just going to make up a graph up here. Let's say we have just the graph of a line. Now, if I'm going to do the vertical line test, I'm going to just draw vertical lines down my graph and see how many times they intersect. If you look, each one of these only intersects one time. So this graph is a function. If it only intersects once, it is a function. Let's look at the few examples below. It says, are the following graphs functions? So let's do the vertical line test on all of these. So if I draw vertical lines, how many times does that intersect? It intersects twice, so we know this is not a function. Drawing this one. Every single time I draw a line, it only intersects once, so that means it is a function. And then this one's a little tricky. People always get mixed up. There's only one possible vertical line I can draw. It's right here. How many times does that vertical line hit the graph? Well, it hits it here and here and here and here and here. So it doesn't hit it once, which some people want to say. It actually hits it a ton of times. It hits it an infinite number of times. So this is also not a function. Now, in talking about functions and graphs, we took a look at domains and ranges. Your domain or your independent variable is always your x values. So domain is another name for x values, and your range is always your y values. So we did a lot of work with domain and range and identifying it. You should be able to write domain and range in interval notation, a list, and set notation. So we'll talk about all three of those now. So if I asked you for the domain of this function, you would be looking at the x values. So the domain, or my x's, are as follows. I could just list them out, and when I list them, you want to put them in curly brackets. So it would be -8, -3, 5, 7. That's a list. I could write it in what we call interval notation. Interval notation is when we use brackets or parentheses. So I know that this one goes from -8, including -8, up to 7, including 7. Or I could write this in set notation. Set notation is when you use like less than or equal to symbols. So I know that it's from -8 is less than or equal to x, because it's my domain, is less than or equal to 7. Let's do the range of this function. So the range, remember, is the y values. So if I were going to list out the range, it would be, let's see, 2, and it's all 2, so I can just write 2 once. In interval notation, well, it is 2, so I could just say it includes 2. And in set notation, I don't even need inequalities at all. I could just say that my y value is equal to 2. Let's do the same thing over here. We have this chart. We can do the domain and the range. So the first circle is my domain. It's my x values. So we'll say the domain is, and let's just do a list for time's sake. My domain, my x values are 3, 4, 5, and 6. And then my range would be -2, 1, and 4. So here we go. It says, if the domain represents all the x values, we must look along the x-axis. So now we're talking about looking at domain and range on a graph. So it has to be the x-axis to identify the domain. So when we are looking along the x-axis, you should be moving your pencil from left to right to decide what the domain of a graph is. So domain is always x value. So if I'm looking here, I should think about having a pencil. And let's see if I can get a straight line to look like a pencil. So if I have this, let's say that's my pencil. So I take it and I'm going to start at the edge of my graph and move from left to right. So where is my graph starting on the left? Well, if I look at the x-axis, it looks like it's at 1, 2, 3, 4, -5 on the x-axis. So it goes from -5. I'm going to write this in interval notation. Up to, let's see, looks like it goes up to, moving my pencil along all the way to the right, stops at 1, 2, 3, 4, +5. So in interval notation, my range is from -5 to 5. If I were to write this in set notation, it would be less than or equal to 5. X is greater than or equal to -5, and then x is less than or equal to 5. Now, we can do the same thing when it comes to range, except range is the y value, so we'll be looking at the y-axis. So instead of moving our pencil from left to right, we're going to be moving our pencil from the bottom to the top. So again, I'll make a pencil. We're going to start at the bottom of our graph. So now we're holding our pencil the other way. It's my pencil. So starting at the bottom of our graph, where are we on the y-axis if we're now talking about range? Looks like we're at 1, 2, 3, -4. So let's start by writing this in interval notation. Goes from -4. Now let's see where the top of our graph goes up to. Goes up to here, which is at 1, 2, 3, 4, 5. So interval notation is from -4 to 5. If I were to write this in set notation, I would have -4 is less than or equal to y, because it's range, is less than or equal to 5. Okay, let's just do a couple more for practice. Let's do domain and range of both of these. Just for the sake of practicing, let's do these both in interval notation. Usually the question will say whether it wants you to do it in interval or whether it wants you to do it in set notation. So the domain of this graph, where does it start on the left? It starts at, let's see, -1. On the left all the way over here, it starts at -1. So it's going to go from -1. Then all the way on the right, it looks like it goes up to, ooh, it's hard to say here. My guess would be that would be the 0.6. Usually it'll be more clear than that. So let's try the range. The range of this graph, so I'm going to start at the very bottom. At the very bottom, the y value, remember, is -2. And what's it go up to? It goes up to, looks like right here, which appears to be 1. This next one, the circle, the domain from left to right, how far left does it go? It goes, let's see, to -4. And then how far right does it go? It goes up to 4. The range, how far down is it? Looks like -4. And how high up does it go? It goes up to 4. All right, last thing we need to talk about is function notation. So function notation is when we start talking about f of x. Remember, that's how you say it. That little red box there is f with the parentheses x. That's how we say something is a function. So for example, you might see f of x equals 3x. That's also the rule for the function. So it's saying whatever your x is, multiply it by 3. Now, a lot of times you're asked to evaluate functions. So let's use f of x equals 3x. It says they want f of 7. So all you do is you put 7 in place of x everywhere you see an x. So we'll say that f of 7 is equal to 21. We're basically just substituting in for x. Let's do a few more. If I have f of x equals 3x and they're telling me they want f of 22, that means everywhere I see an x, I'll put a 22. So I'll say f of 22 is 3 times 22. So that would be f of 22 equals 66. Next example, they say f of x equals 2x plus 1. What is f of negative 3? So wherever I see an x, I'll put a negative 3. So f of negative 3 equals 2 times negative 3 plus 1. So f of negative 3 equals negative 6 plus 1. So f of negative 3 equals negative 5. Just evaluating the expression here, but with function notation. This last one then says g of x. Don't be confused if it says g of f or f of x. It still just means it's a function. And they want us here to find g of 2 and g of negative 3. So we'll do it twice. So first let's find g of 2. G of 2 will be 2 squared plus 2 times 2 minus 1. So that'll be 4 plus 4 minus 1. So it's going to be 8 minus 1 is 7. So g of 2 is equal to 7. Now let's do g of negative 3. So g of negative 3, everywhere I see an x, I'll put a negative 3. So it'll be negative 3 squared plus 2 times negative 3 minus 1. So just be careful. A negative number squared is a positive 9 minus 6 minus 1. 9 minus 6 is 3 minus 1 is 2. So g of negative 3 is 2. Now, there's one last thing we need to do, but I wanted to mention this little extra credit opportunity. So, for watching the video and watching it all the way through, there is an opportunity for extra credit. In order to get extra credit here, if tomorrow on your Unit 5 packet, on your Unit 5 packet, if you put a star next to where it says name, you will get an extra credit point on your packet. Now, keep this a complete secret to those of you who didn't watch the video. You don't want to tell all of your friends, because if more people put stars than how many views we have, no one will get extra credit. So just quietly when you're in class tomorrow, put a star next to where it says name. Don't say anything to anyone else, and that's how we know you've watched the video, and it'll be worth extra credit points, okay? But don't tell anyone, because then you'll mess it up for everyone if we have too many stars and not enough views. All right, so last thing, graphing function notation. It says, how do you think we might graph the following? Graphing with functions is really not any different than regular graphing. This notation here is the same thing as saying y equals negative x plus 3. So if you can graph a line, you can graph in function notation. So let's graph this. Y equals negative x plus 3. So my slope is negative 1 over 1. My y-intercept is 3. So just that g of x, don't let it confuse you, or f of x or k of x. It'll always just mean y. So we'll go to 3. We'll go up 1 over 1 to the left because it's a negative slope. Okay. Connectors will look nicer because you'll always have a straight edge. And then what we can do is answer some follow-up questions. So they want g of negative 3. So it's saying at negative 3, what is our function? So we can actually substitute in. So g of negative 3 equals negative 3 plus 3. So g of negative 3 equals 3 plus 3, which is 6. And this should follow on your graph as well. So if we're at negative 3 on the x-axis, we follow it up, we're also at 1, 2, 3, 4, 5, 6. So that works the same way. You can just get it from the graph. So let's get g of 1 from the graph. If we're at 1 right here, and we follow it up, we're at 2 on the y-axis. So g of 1 is 2. So you can use the graph to help you figure out values for your function. Hopefully you found this video helpful. Don't forget about that star extra credit for tomorrow. Keep it a secret so you can earn the extra credit and we know you've watched the video. Talk to you guys later.